Coming today to a YouTube channel near you. The sun at 304 angstroms. There'll be thrills, chills, plasma filaments bigger than your entire planet. There'll be views at 171 angstroms, showing no sunspots. There will even be views of the sun's magnetic field strength lines. If you fail to subscribe to Smash-O-Mash, you may not receive these daily reports. This channel not yet rated. Taking a look at the real-time solar wind data. Nothing too significant going on with the BTBZ. We see a now off again coronal hole magnetic connection, as you see right here with these blue portions in the near the 180 degree line of the phi angle. Solar wind density 7.19 protons per cubic centimeter, and solar wind speed has dropped also to 361 kilometers per second. Head to spaceweathernews.com for some additional data here. X-ray flux is still pretty flatlined, actually very low. And you see that on again, off again phi angle connection there to the sun. There's your magnetometer. Planetary K index down to 1. Your Cygnets forecast. I would just like to note one little thing here, and that thing is this portion of the interplanetary magnetic field. The magnetotail regularly curls up back toward the Earth, causing big disturbances in the non-sun side of the magnetosphere. The magnetotail is part of the interplanetary magnetic field, and you have these reconnections and disconnections, explaining a lot of perturbations in some magnetosphere views. Moving on, here's your electron flux, still a little on the high side, but in a relatively smooth range. Charging hazards are minimal, and the F2 ionosphere layer is looking fairly on the normal side here, save for this standard operating procedure South Atlantic anomaly. Also a little bit on the charged side in the extreme south, but fairly non-anomalous there on the F2 layer. There's your aurora forecasts. Let's look at the geospace perturbations. Noticed a little bit of activity going off there. Let that play through. Some activity in the southern Indian Ocean, as we've been seeing. Nothing very extreme. And let's go to the source of the incoming field-aligned currents here, the poles. Look at the magnetic perturbations there. As this is the location where the primary input of the sun's radiation hits the ground. Here are your geospace movies, looking at the magnetosphere first in velocity. You see some slower wind speed rolling in there. That's what that dark red was. Lower velocity wind. Nothing too extravagant there. Next, we'll look at the density, and I can't stress this enough. White is low density, blue is high density. By the way, this is measured in protons per cubic centimeter. And finally, we'll look at the pressure, which is looking quite weak, as would be expected with a mid 300 kilometers per second solar wind speed. We'll let it play through anyway. Small increase in pressure and a downtick. Next, we'll look at the Gong 2 data here, and we'll see why there haven't been any significant spikes in the magnetometer. Please note this data is 1 hour and 52 minutes old. You can see the incoming magnetic environment that the Earth will experience is going to be fairly uniform, although keep in mind that magnetic environment can change instantaneously with absolutely no warning. Look at the last 14 hours or so of earthquakes here. We see a 5.0 in Indonesia, 4.6 in the Philippines. Alaska gets a 4.0, and a series of other quakes around that same area. Mexico, 4.5, India, 4.6. Puerto Rico gets a deep 2.8. 5.2 strikes New Zealand. 4.5 in Argentina at depth, which should keep Argentina on alert for a 5. And most recently, Russia with a 4.6. And I think I got too many quakes on the map. Let's just ignore that. Volcano situation. So far today, we got Shivaluch with a 23,000-foot ash plume. Explosive activity continues. Abiko with a 7,000-foot ash plume. Tucono, 7,000-foot ash plume. Popocatépetl seen from satellite erupting. Fuego. Looks like volcanic ash dispersed. Reventador detected in satellite. Sabancaya, intermittent emissions to 24,000 feet. Also, Etna's been going off and exhibiting earthquake activity as well. A little unsettling. Next, we've got astronomers detecting the brightest quasar yet known, looking very far away into the very old universe. We'll leave links to the article. Now, as far as the mechanism that causes the gravitational lensing, we're not so sure that it's caused by gravitation. But there is some lensing occurring. We'll give them that. Without going too in-depth into the cosmology of this, we'll just say read the article and keep in mind that this throws into question things like the age of the universe. Seeing a system as organized as a quasar, which is a giant ultra-active galactic nucleus, totally throws the age of the universe into question. They'll try to figure out ways to explain how something can be so organized and yet so old. Next, we've got Science Alert with an interesting article stating that our sun will become a solid crystal as it dies, joining billions of others out there. Not sure what to make of this one, although with a lot of electric universe theories out there, such as the liquid metallic hydrogen model of the sun basically already is a crystal. It's just a liquid crystal. Interesting in this article is the fact that, here's a quote, "This is the first direct evidence that white dwarfs crystallize or transition from liquid to solid. So does that mean that this particular physicist from University of Warwick does not believe the sun is made of a gaseous plasma? That's interesting. Now this is all part of the still part of the lambda cold dark matter model of the universe, trying to explain how stars evolve, you know, the less massive ones, the way they evolve to a black dwarf eventually. But it is an interesting article. It seems like they're trying to worm their way into electric universe theory here without fully embracing the implications of the physics. Perhaps a step in the right direction, and perhaps just misguided. Also on Science Alert, turns out Starman's got something else in his payload. Were you aware? Turns out there's a data storage device in there called ARC, which holds about as much information as, I think they said 17 Blu-ray discs? 7,000 Blu-ray discs. 360 terabytes of data on a thing a little bigger than a postage stamp. Check it out. Possibly will remain stable for over 1 billion years. Way to do some forward thinking there, Elon. Really, this is the ultimate time capsule ever built by mankind. And we were going to cover an article about a lonely galaxy here on phys.org, but we're sorry. They are unable to display this page at this time. We were also going to cover another one about gigantic star explosions, but yeah. Thanks, phys.org. Real helpful. And let's give you a little view of the 335 angstroms. Take a look at that northeast corner where the filament activity was going on to see how it plays out in this wavelength. Let that play through. Thanks, subscribers. Please don't forget to like the video if you enjoy the content, and subscribe for more daily videos such as this one, where we are looking at all of the most tiny details of solar activity. Thanks for watching. Be safe out there, folks. Remember, when you're driving, don't drink. And if you drink, don't drive. Or just don't drive.